My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. On February 2nd, 1993, my parents gifted me a blue Webster's Concise English Dictionary from Barnes & Noble. I'm actually holding it right now, and I know the date because it's written on the inside cover. And it's just the type of gift that any librarian mother and college professor father would give to their 12-year-old son, one who on a good day could boast a solid C- average. On the front in red it reads, over 125,000 words and meanings. One of those 125,000 words is naturalistic on page 316. Listed as a derivative of the adjective natural, it is defined as something that shows things as they really are. Literature, art, and cinema are often cited as examples to help illustrate the description. Although today we could use automotive as well in concert with naturalistic, adding to it the importance of human factors. And for this, I'll go to the Wikipedia definition. Human factors in ergonomics is the application of psychological and physiological principles to the engineering and design of products, processes, and systems. So how do we take what these definitions are saying and apply them to the vehicle, and apply them in a way so that everybody who is inside that vehicle gets home safe? This is the core question at Seeing Machines, and it has been for over 20 years. 2 decades ago, Seeing Machines was occupying only a small space at the back of a robotics lab at the Australian National University. But their ideas were big, and perhaps ahead of their time. Precisely this idea that driver monitoring someday in the future would play a key role in developing a safe and potentially crash-proof vehicle. The original idea as imagined by Seeing Machines is increasingly relevant today, especially with the advent of driver monitoring systems, or DMS for short. And in the time since that small robotics laboratory, Seeing Machines has developed a range of solutions based on eye tracking technology. Whether we take the DMS discussion from the features and technology side or the regulatory side, it's evident that DMS and other in-cabin innovations play a role in creating safer cars. But in order to do that fully, DMS and exterior ADAS sensors have to be on the same page, and consumers have to trust the technology.
Moving at the speed of mobility, this is AutoVision News Radio with Carl Anthony in Detroit, Michigan.
To share more perspective on this is Seeing Machines CEO Paul McGlone. As a leader of one of the Australian Capital Territory's largest private employers, Paul brings significant strategic growth experience to Seeing Machines, as it aims to have its technology at the center of what is a global push for enhanced safety across the world's transport systems and roadways. Paul has experience in logistics and supply chain management, having worked with the automotive, rail, and aviation industries throughout his career. He holds a Master's of Business Administration from the University of New England and a Master's in Applied Business Research from the Macquarie Graduate School of Management.
Thanks, Carl. Seeing Machines is actually 23 years old, so a bit of a veteran in the space. But way back then, at the beginning, we were founded through a group of young scientists at the Australian National University, which is a very prominent university for engineering science. Those 2 founders are still with us today, which is amazing. The company focus its core area of endeavor around eye tracking, and in particular, the relationship between humans and machines, this human-machine interface. Today, we're focused on transport. We operate in 3 vertical markets within, or segments within transport, and that's automotive passenger vehicles, that is new cars, essentially what we call fleet or aftermarket, trucks, buses, large commercial vehicles, etc., and aviation. And in aviation, we deploy our technology into pilot training simulators, aircraft, and air traffic control environments. We are a technology company. At our core, it's about safety technology, but there are layers around that core safety technology that are designed to improve the human experience and the human-machine interface but all of it is designed around our core purpose, which is to ensure everybody gets home safely.
When we hear things like ADAS or assisted driving, we tend to think an awful lot about external sensors, but in-cabin monitoring plays a role. Why is it important that when we talk about ADAS, we also make room in the conversation for something like DMS?
Yeah, Carl, that's a great question, and it's one that's been asked of us more and more frequently by our customers. I put this in the realm, ADAS is still a really important area, and probably the acronym that gets most talked about, certainly more than DMS and OMS at this point in time. But if we consider the notion of sensing, whether that be exterior sensing or interior sensing, I think this is where it's all going. And to be able to enable an environment where safety is enhanced by bringing the external sensing and the internal sensing together. Demand for that integration is increasing in almost every tender that we get from OEMs these days, and all of the technical conversations that we have. There is a desire to bridge the gap between what the car can see outside and what the human is seeing from the inside, or whether in fact they're paying attention at all. So that's becoming a much more important part of the conversation today, and in fact a reality in new cars.
The first application for seeing machines was in the mining industry, where vehicle operators are driving monotonous routes for hours on end, leading to fatigue and distraction. And mining indeed was an excellent proving ground for seeing machines, given its importance to Australia's economic landscape. According to the Department of Foreign Affairs and Trade, in 2018 and 2019, the mining sector accounted for 8.5% of Australia's GDP. The key learnings from mining were applied to trucks and buses, and then eventually to everyday passenger vehicles. Taking this from the perspective of passenger vehicles, there is a correlation between safety and synchronization. And when I say that, I'm not discrediting or ignoring trucks and buses and the other work seeing machines has done, as I'm certain that the principles are the same or remarkably similar. But I'm just taking this more from the automotive perspective here, everyday cars. But this idea of safety and synchronization is key.
If we consider crash avoidance systems, in this environment, we've got a pretty advanced safety system, of course. It's scanning the exterior of the vehicle, sensing imminent threats, and is able to make real-time decisions. But there's a big assumption around taking back control or what the driver is doing in order to be alert to the problem and ultimately prevent or minimize accidents. In these kinds of systems, the main role is to, of course, avoid the threat at all, or if unavoidable, to really engage these other safety systems within the vehicle to prepare for impact. And that might be, for example, the trajectory of the airbags or the tension of the seat belts. All of these kind of unique and initially disconnected technologies can be brought together to deliver better outcomes to either avoid a problem or minimize the risk of the problem should it emerge. Obviously, in an accident environment, the car and the driver may only have a very short period of time, a second or two, to react. But if the system were able to recognize that the driver was alert, well, then it might take a specific course of action. If the vehicle could determine that the driver is not engaged and not aware of the risk, well, they can bring them back to the job of driving. Now, this is a really important action, specifically if it can be done in a way that avoids the vehicle making its own decision, either by, applying braking or what have you. And if we consider airbags, as I just mentioned, airbags can be adjusted and deployed using signals from the seat sensor and the seatbelt sensors. But imagine an environment where the vehicle understands the size of the driver or the passenger or the occupants, their position in the vehicle, their weight, gender, how they're sitting, are they holding something? Well, that could enable the engagement of the airbag based on human information that can minimize harm.
When it comes to autonomous cars, and no doubt you've read about this and maybe you've even discussed it with a friend or a colleague, but the notion of the vehicle handing back control to the driver. When does that take place? How does it take place? How long should that transition take? And so on. Seeing Machines approaches this from the perspective of the two key terms we discussed at the beginning, naturalistic and human factors, but doing so in a way that builds consumer trust.
Yes, that the handover discussion is very, very broad one, and it's almost unending. First and foremost, there is a requirement for a deep understanding of how humans act and interact and react in a naturalistic environment, like a driving environment. So from our perspective, we've got a deeply experienced team of scientists, human factors scientists, who specialize in the HMI, human-machine interface design. Some important elements of this are, of course, understanding specifically and exactly how humans act and react, as I've mentioned, in this naturalistic environment, using as many test cases as possible that improve the performance of whatever outcome is designed, but doing that in a way that materially reduces annoyance. In order to make these systems effective, and in order for users, consumers, humans to trust them, well, they have to deliver signals and passive and active safety outcomes that are as close as possible to this true positive environment. And the greater the variance between what is true and what is not, well, that increases the level of concern and distrust, which has an overwhelming impact on the consumer's belief and ultimately the take-up rate of this technology. A lot of words, but human factors design is mission critical as a starting point. Now, when you apply this understanding, that's knowing the driver or the occupant, knowing what they're doing within a context, where they are, what their attention state is at any given point of time. Well, then there's an opportunity to feed those signals or feed that information into other systems within the vehicle, and then those systems can act accordingly. And essentially, they'll enhance the performance of the experience, the intuitiveness of the external sensing or the ADAS systems. They make them work in a more synchronous way with the driver and the driver's current behavior. Are they alert to the risk? Are they not? And ultimately, they support increasing driver acceptance. And that driver acceptance and trust is, that's an enduring program, obviously, and companies like ours and OEMs and other technology companies need to continue to work on ensuring that the technology can be trusted. Given the current trajectory of semi-autonomous driving features, we think becomes one of the most important aspects of this whole sensing integration opportunity.
As Paul mentioned, Seeing Machines has a team of human factors scientists who apply this understanding to the machine interface. To date, Seeing Machines has acquired over 14 billion kilometers of naturalistic driving data, including more than 40 studies across simulators, test tracks, and on-road environments. These data sets inform Seeing Machines as they develop optics and processing technologies that more accurately measure, assess, and detect whether the driver has surpassed a threshold of risk, and if so, take action to intervene in real time. So far, they have logged nearly 50 patent applications. 25 of them have been granted as of the time of this broadcast, with another 100+ registered trademarks worldwide.
Human factors, we would say for us, is the big differentiator in what we do. And at the level of first principles of design, we apply our human factors science and insights and people to this core problem of how does the human behave in this environment, and what are the things that can be done to enhance the safety outcome and simultaneously enhance the user experience. Because we know that we can develop technologies, frankly, relatively easily, do certain things, observe certain things, and if we're not concerned about the user experience, well then, we can certainly drive a whole range of outcomes that would be positive. The issue is humans are influenced by their environment, and they're continuously drawing on the signals from that environment to adjust their behavior. So if the human in the driving environment is continually annoyed by a set of signals or actions that aren't considering how that human, which is in fact a customer or consumer, is engaged, the natural response is for the human to disengage, to turn off or turn it off. And so that gets back to really degrading the whole purpose of the technology in the first instance.
On July 6, 2022, the new General Safety Regulation from the European Commission took effect, introducing, and I quote, a range of mandatory advanced driver assistance systems to improve road safety, establishing the legal framework for the approval of automated and fully driverless vehicles in the EU. In its press release, the European Commission writes that the new safety measures will, quote, help to better protect passengers, pedestrians, and cyclists across the EU, expectedly saving over 25,000 lives and avoiding at least 140,000 serious injuries by 2038. The European Commission presented the revised General Safety Regulation in 2018. The European Parliament and EU member states adopted the regulation in November 2019, with the latest update taking effect in July 2022. The new General Safety Regulation states that an attention warning system that can detect driver drowsiness and/or distraction in real time is mandatory for all road vehicles across Europe from July 2024 onward. Road vehicles as defined by the European Commission include cars, trucks, vans, and buses. At the time of this broadcast, the latest generation of the Seeing Machines Guardian solution has been independently tested and verified to meet the European Commission's General Safety Regulation for drowsiness detection. In order to receive a 5-star safety rating from Euro NCAP, automakers must include a range of high-performing ADAS and DMS technologies. Seeing Machines was the only DMS supplier to sit on the advisory board for this protocol.
So, Carl, we've worked for several years now very closely with Euro NCAP. In fact, we presented the first science to Euro NCAP and European Commission many years ago, and the objective there was to demonstrate that there was a way to intervene in this problem. And what is the problem? The problem is that there's, circa 1.3 million road deaths a year and countless millions more affected by those tragedies. We determined that there was a way to assist in reducing that risk. We support our OEM customers to implement the safety features required by NCAP. We also have an eye into the NCAP technical roadmap because we work with them to advise on certain aspects of this very closely. We're seeing that the OEMs today are kind of racing to the finish line to meet the NCAP requirements, but they're also very, very focused on, all right, what's coming next? How far ahead do we need to be? It's moving from driver monitoring to occupant monitoring, from fatigue, distraction into intoxication and other things. And so there's a very, very long roadmap that will be driving safety in this space. And we're really pleased about that.
I go back and flip through my Webster's Concise English Dictionary, the gift from my parents in 1993 that I've had for all these years. Page 384, the word purpose is right above the word per. Of course, there's a cat example, but another supplemental example given for per is a low noise made by a powerful engine. So it's fitting since we've been talking about cars. One entry above per, purpose, as defined, a noun, to aim or use according to what was planned intentionally, as an adjective, purposeful, to be intentional with an aim in view. Equally as important as the technology is the purpose behind it. Paul, as Seeing Machines CEO, has worked diligently to ensure clarity around the organization's purpose and to communicate that accordingly. The mission of Seeing Machines is a good one, to help people get home safely. And because that's a good purpose, the question becomes, how do we continue to rally everyone around it? We go back over 2 decades to the beginning, the robotics lab at the Australian National University. And if you've ever started something, you've ever had a project that was your baby, From the very first thought that everyone may have had in that laboratory of what seeing machines could become with that purpose, all the way up to today, where they're helping shape legislation and over 1.3 million cars feature seeing machines technology. What I wanted to know from Paul is, how do you do it? How do you make it work?
If we want to be the company that gets everyone home safely, what are the important things that we need to achieve to bring that to life? Well, we need to be a sustainable business. We need to be a leader in technology. We need to have highly engaged people that are working aligned and in the same direction. And we need to deliver for customers in a way that meets our commitments. So if you take those high-level objectives, then you can drill them down into more specific objectives, or what we might call KPIs or OKRs, depending on the nomenclature in your organization. And we convert that principle, let's say being sustainable, into a set of actions that are relevant to people right down the organization. Now, what does being sustainable mean? We have to be financially viable. To be financially viable, we have to develop products that are commercially saleable. We break down this notion of being sustainable into, let's say, half a dozen more granular metrics that are linked to financial performance. And then suddenly you've got a brilliant way to link purpose to what somebody does. And we do that across each of the 5 or 6 categories that I mentioned. Now, that's a formal process that we engage in here. It's our way of linking daily activity to long-term purpose. Now, that's the structure of what we do. So then let's talk about the behaviors. Let's say perhaps the behaviors that I have to demonstrate as a leader. I've got to be open. I've got to be open to all. We're a high-tech company with 600 employees, whether that be through town halls, coffee room meetings, one-on-ones, walking the floor, skip meetings. There's a whole range of process-orientated activities that we put in place here to assist in delivering on those objectives, low-level objectives that contribute to purpose. And we keep going. We do it again and again and again and again and again. And I think importantly, you got to do what you say. And so that's a very big and important thing here. If you're going to say you do something, make sure you do it. If you can't do it, well then let your audience know in advance so there are no surprises. And if you bundle all of those things together across the 5 or 6 key categories that drive purpose, well then I think you've got a great chance of making it.
To learn more about seeing machines and the general safety regulation from the European Commission, see the links in the show notes. AutoVision News Radio is available on Spotify, Apple Podcasts, Podbean, and more. In Detroit, alongside Paul McGlone, I'm Carl Anthony, AutoVision News Radio.